One thing that 3-4 method students usually find quite challenging is integration by recognition. There's a couple of signs that they want you to use it. Okay, so these questions ask you to find a derivative and hence find a non-standard antiderivative. It's going to be one that if you look at the thing that you're trying to integrate, you're going to sort of be like, he never taught me that one. So these questions often, but are not always, product functions. So they tend to be trying to reverse up the product rule, which again, all I'll teach you this year is reverse chain. So what they'll do is they'll ask you to find a derivative and hence use that derivative to anti-diff back. Right, so I'm going to go through an example with you first of all and see how it works. This is a fairly entry-level situation. So find dy dx where y is equal to x squared e to the x. I'm going to say this, let f of x equal y equals x squared e to the x. So let's find f dash x, its derivative. All right, so the way we're going to do that is we're going to use the product rule. So u equals x squared, v equals e to the x, du dx equals 2x, and dv dx equals e to the x. Feels weird to be doing this after doing so much integration, but yeah, we've got to be comfortable with this as well. All right, now let's state what f dash x is. F dash x is equal to u dv dx, that's x squared e to the x, plus v du dx, which is 2x e to the x. All right, now what's going to happen is that we're going to integrate f dash x dx, and what we want to do, or what we know will happen, is it will return us to f of x. Okay, so, or plus c I should say. So when I integrate this, it'll return us to the original function. So let's do that. Now I know I haven't paid any attention to this just yet, but let's just see what happens. So I'm going to integrate x squared e to the x plus 2x e to the x, okay, and I know that that will return me to f of x plus c. Okay, so what was my original function? It was x squared e to the x. All right, now what? I'll ignore the plus c at the moment. I'm just going to slap it on at the end. All right, so I need to integrate that, or when I integrate that, I know that the answer will be that plus c. That still doesn't help us with this, but I recognize something in this to match it up with this. So what I'm going to do to this is actually take out e to the x as a common factor. So I'm going to integrate e to the x, and that becomes x squared plus 2x. And this side here is still x squared e to the x. All right, so when I integrate this, which is the same as this, I get this. Now notice that that is exactly the same as that. Okay, e to the x, x squared plus 2x. So when I integrate that, I get this. So what I'm going to note is that when I integrate this, the answer will be x squared e to the x plus c. Right, let's just check that out on the calculator to make sure we are on top of this. Integrate. There it is there. Okay, so why is this a thing? Well, notice that this here is an integral that we couldn't perform because what we've got is one function being multiplied by another. So typically we couldn't integrate this. So the only way we can do it is with a bit of a helping hand from the examiner, okay, from someone who's writing this question. So they'll help us out by trying to get us some sort of derivative first of all, and the derivative will kind of point to something that we can do to allow us to get the integral. Something that we can recognize in the derivative will get us the answer to the integral. Okay, so that's why it's called integration by recognition. All right, let's try this one out. Differentiate x sine x and hence find an antiderivative of x cosine x. So again, if I ask you to do this, x cosine x dx, you would not be able to do that. Okay, so at this point in time, if that was my only question, the only way you could do that is actually on the calculator at the moment. I haven't taught you how to reverse product. All right, so let's follow on from what they're telling us. So differentiate that. So I'm going to say let f of x equal x sine x, where u is x and v is sine x. Du dx is 1, dv dx is cosine x. Right, let's get f dash x. So it's going to be u dv dx, which is x cosine x, plus v du dx, which is sine x. Okay, now I like to write this line here. I know for a fact that when I integrate f dash x, what I just found out there, for the independent variable x, I get f of x plus c. Okay, it'll take me back to the parent function with some sort of a constant on the end. So let's just try that and see what happens. Okay, now I know that f dash x, I've just found it, is integrate x cosine x plus sine x dx equals, what was my parent function? F of x is up there, so it's x sine x. And I'm just going to put the plus c on at the end, otherwise it's going to hang around and annoy me. Okay, so that returns me to the parent function plus c. Now, how does this help me with the integral? So what they want us to do is find an antiderivative of x cosine x. That's the antiderivative of x cosine x plus sine x. I recognize, note the use of the word recognition, I recognize that that is x cosine x. So if I could just get this sine x over to the right-hand side, then I can make integral x cosine x the subject. So what we're going to use is that rule with integrals where I can kind of, in inverted commas, pass the integral through to each thing that we're attempting to integrate. So this is the same as x cosine x dx plus integral sine x dx, and that equals x sine x plus c, but I'll just wait to the end. All right, now what we're going to do is I'm going to subtract this from both sides. So I've got integral x cosine x dx equals x sine x, take away integral sine x dx. Got my dog banging at the door trying to get in, and it's hard to concentrate on hardcore maths when that's happening, but I think we're going all right. Okay, now integral x cosine x dx is this. Okay, so to finish the job here, all I need to do is actually just integrate sine x. That's x sine x. Take away. Now, what is the integral of sine x? I'm just looking at my formula sheet up on my wall here. It's negative cosine x. So it's already a negative, and the answer is negative cosine x. So that changes to a plus. We'll flip that to cosine x, and we'll put a plus c on the end. So let's sum up what we've done here. X cosine x dx, when I integrate this, this must be the answer. And again, I can only do that. So at the moment, if that was the only question I gave you, you could go, that's not fair, Mr. Miller. I don't know how to integrate or reverse product. So the only way we can do it is by getting you to do something else, a derivative, and use that derivative to manipulate it so you can get the integral that you're after. Right. So I implore you to double check your integration by typing it in. So x times cosine x, and we've got x sine x plus cosine x plus c. All right, doing all right. Okay, so this was on the 2014 SAC and certainly a difficult problem. Okay, this is question 6. This is probably one of the last questions on the SAC. At school, Jenny is in maths methods and she's asked to differentiate this function here and found the derivative to be this, so that she's correct. All right, I'll do that. I'm going to say let f of x equal log e x over x. All right, so what do we got here? Well, we've got the quotient rule. So I know I said that it's usually product, but quotient works as well. So remember, if you jump straight to part B as well, you would have to try and integrate something that was reverse quotient, and we just can't do that. I haven't taught you that. All right, let's get its derivative. Log E x is u, v is equal to x, du dx is equal to 1 on x, dv dx is equal to 1. Okay, let's get the derivative. Okay, so f dash x is equal to, okay, so it's v, which is x over x, which is 1, take away, so v du dx, those multiplied together, take away u dv dx, which is log e x, over v, which is x squared, as required. All right, as required. Okay, hence evaluate this thing. All right, so I always start with going, all right, so I know that this is recognition. So this is part B. So I know if I integrate f dash x for the independent variable x, I'm going to get the parent function plus c. So now I just insert the derivative, which is 1 take log e x over x squared, and dx equals f of x. Now what was f of x again? There it is there, log e x over x plus c. All right. Now, what I want to do is evaluate this thing here. So what I want to get is I'm going to get it into this form first and then slap the terminals on to get the evaluation. So I need to get it looking like this, log e x over x squared. And at the moment, it's not looking like it. But I can recognize that part of it is in here. Part of it is there. So here's what I'm going to do. I'm going to manipulate this a little bit. Integral 1 over x squared, take away log e x over x squared dx equals log e x over x. I'm going to drop the plus c for the moment. All right, now what I'm going to do is pass that integral across each term that I'm attempting to integrate. I'm going to say that this is the same as integral 1 on x squared dx, take away integral log e x over x squared dx equals log e x over x. Now, have you noticed what I've done here? This integral here, I've got it. Okay, that's what I'm actually trying to integrate, log e x over x squared, log e x over x squared. So I've got the integral that I'm after. I just need to get rid of this part here and the negative sign. Right, so let's deal with this part here. I'm going to say that this is negative log e x over x squared dx equals log e x over x, take away. Should we do this all? Nah, let's not do it all in one hit. I'm going to do this though. I'm going to write this as x to the negative 2 dx plus c. All right, I'm also now going to pass the negative across and then integrate at the same time. So that is integral log e x over x squared dx is negative log e x over x. Now that negation, so this negative, I'll divide this by negative 1 and divide both of these terms by negative 1. I'm just going to hold off on that. Now negative divided by negative, that should be a positive, but I think when I integrate this, it will be a negative again. I'm pretty sure that that's going to be a negative. Now, what's the integral going to be? So x to the negative 2, add 1 to it, which is x to the negative 1 over negative 1, which is the same as negative x to the negative 1 over 1, which is exactly the same as negative 1 over x. Okay, so that's going to be negative 1 over x. That negative becomes a positive, but then will become negative again with that. Okay, so that's 1 on x. All right, so I believe that the antiderivative to this is this plus c. Let's check it out to see whether I got that right. Shift integrate ln x over x squared. What have they done? Yeah, they've just combined it, taken out -1 as a common factor, put it over x. So that's a move worth doing. Let's tidy up a bit. So negative, let's write it as log ex, take 1 over x plus c, and then, whoa, run out of room really badly here, equals negative log ex plus 1 over x. All right, so now that we've got this integrating to this, what I can do is grab that and start to put those terminals in to evaluate it, okay, to get the signed area between e squared and e. All right, so I'm just going to use this space up here. So I'm going to note that the integral is going to be negative log e x plus 1 over x between e squared and e. Right, let's chuck in e squared first. So I've got negative log e squared plus 1 over e, take away negative log e plus 1 over e. All right, okay, now, tough sack question. Whoa, tough sack question. Right, this 2 will come out here. That'll be log e, which is 1. 2 plus 1 is 2. That's going to be -2 over e. Right, let's just see whether I substituted correctly there. So I'm just going to check this on the calculator. So ants with x equals shift e to the 2. That's not a good sign, is it? What did I do wrong? Okay, 2 things. All right, so log e is 1. 1 plus 1 is 2. I copied down something wrong. No, that's stupid. Okay, so there's my mistake. I'm looking at the wrong thing. I'm looking at log EE. This is the problem when you run out of space, girls. All right, so this 2 goes to the front. 2 plus 1 is 3. 3 gets negated. This should be -3 to the E. -2. Where is -2 coming from? Because I'm subbing in E squared. Boy, oh boy. Okay, so I'm struggling a bit here with the lack of space, and I'm making excuses, but anyway, when I put in e squared should have gone here, e squared should have gone here. Okay, lucky I checked that on the calculator. All right, take away. All right, let's see if I can get this right. Negative, EE is 1, 1 and 1 is 2, negate the result. That should be a bracket on there as well. That should be a bracket on there as well. So that's -2 on E, -2 on E. Let's see if I get that one right. Thank goodness. Okay. So this is going to be -3 on E squared, take away -2 on E. That's the same as -3 on E squared plus 2 on E. You could reverse those up if you wanted, but there's our answer. All right, so quite a difficult problem. Now, a couple of things to note. This was on the SAC. Okay, so if you think that's hard and some of the substitutions are hard and, oh, Mr. Miller, you were using the calculator. Well, yeah, and so could you. Okay, so on the SAC, you're allowed your calculator. Okay, so don't forget you can check your work that way and see how you're tracking with it. Do the substitutions, make sure the substitutions are going in right, etc., etc. Hell, you can even get the answer. I mean, you could just integrate that straight up on the calculator and know what the answer needs to be. Okay, so don't forget that on the SAC, if you're asked to integrate something and you don't know how to do it, all right, just slam it into the calculator as well. This one, though, does require you to do a lot by hand because it says hence. It means you've got to use part A to answer part B. All right, now let's see what else I've got for you. Oh, now this one here, what we're going to do is we've already kind of done this. Okay, we've already done this one in this example. So in the class, so that's this one here, x antiderive x cosine x. So I'm just going to pick it up at antiderive x cosine x. I know that the answer is x sine x plus cosine x. So it's x sine x. What was it? Plus cosine x. Oh, I've got a bad memory. X sine x plus cosine x. Plus c we don't worry about because what we're going to do is calculate that. Pi on 2, pi on 6. So we're not going to do this. So use the result of part A. That would be use the derivative to get this. That would be the integration by recognition. All right, so let's get our answer going. Not a lot of room here, by the way. So let's slap in pi on 2. So we've got pi on 2 sine pi on 2 plus cosine pi on 2. Take away pi on 6 sine of pi on 6 plus cosine pi on 6. Okay, the sine of pi on 2, it's going to be 1. So that's going to be pi on 2 plus the cosine of pi on 2 is 0. Take away. Sine of pi on 6 is half. That's going to be pi on 12. Pi on 6 times a half is pi on 12. Cosine of pi on 6 is plus root 3 on 2. Yeah. Okay, so this then is going to be pi on 2, take away pi on 12, take away root 3 on 2. All right, times 6, that's going to be 5 pi on 12, take away root 3 on 2. And that's in that form there, where A is equal to 5 on 12, B is equal to negative root 3 on 2. Okay. All right, these are tough, these ones here, so you've got to sort of sift through the muck. Right, given that this is equal to this, then find this integral. Okay, so what I'm going to note is f of x is equal to x e to the kx, f dash x, so d dx is operator notation. All right, so the derivative of this, they're telling us, is kx plus 1 e to the kx. And what they want us to do is find this integral. Right, so what I think, so now that they're getting us to integrate here, this is product, so I need to reverse product. Don't know how to do that, so I'm going to try the recognition technique. So I know that recognition involves taking f dash x dx and returning it to the parent function plus c. All right, so this is f dash x here, so I'm going to write that in. Kx plus 1 e to the kx is dx is equal to f of x, which is x e to the kx. All right, now how does this help us out? Plus c as well, by the way. Okay, I need to integrate that. Okay, I can see it. All right, so what I'm going to do is expand this out. I'm looking to recognize something. Okay, so when I expand this out, I'm going to get e to the kx by kx, and plus e to the kx dx equals x e to the kx plus c. All right, now how does that help us? I'm going to yank the k out the front there and leave x e to the kx there, dx plus integrate e to the kx dx equals x e to the kx plus c. All right, now what I'm going to do is so what have I got here? I've got the integral that I'm after. Integral x e to the kx, integral x e to the kx. So first of all, I'm going to throw this over to the other side, and then I'm going to multiply by 1 on k on both sides. So that's going to be x e to the kx, take away integral of e to the kx dx, and all of that is going to be multiplied by 1 on k plus c. Right, now I think that some of these, they haven't actually simplified it, so that's looking good, that one there. Yeah, that's it. All right, so yeah, it's D. All right, so there's the work there. Fair few questions from 11H. There's also a worksheet that I will put on Google Drive. There's also going to be another worksheet that we do in class for the second half of the double, which I'll also work through and have a video for that includes the work solutions. There's going to be some really tough problems on that one.